Ever wonder how your data actually travels across networks? When you send a file to another computer, it doesn't just magically appear, it goes on a journey. But what happens when your PC doesn't even know where to send it? In this video, I'll break down exactly how IP packets find their way, even across different subnets. Want to see the hidden process that makes networking work? Watch now.
Delivery of host-to-host packets involves a series of processes. We will see them in detail when the PC communicates with the server that is on another subnetwork. The PC wants to send this data to the server. The app that manages its data does not need a reliable connection, so it's going to use the UDP protocol. UDP prepares its head and passes the PDU to the IP protocol, telling it that it wants to send this data to the server. When the PC analyzes the destination address, it realizes that it is not part of its subnetwork. So it will send it to its default gateway, which is the local router's IP, 192.168.1.254. The IP protocol encapsulates the PDU in a packet of 3 layers, and transmits it to layer 2, with instructions to give it to the default gateway. The problem is that the PC does not have the MAC address of its gateway. To distribute the package, the PC needs the MAC address of the default gateway, and the PC's ARP table has no input. The PC must therefore first solve this problem before continuing. The package is currently put on hold until the PC gets this MAC address. The PC will use the ARP protocol to ask the router for its gateway MAC address. When the router receives this request, it sees that inside the ARP package, which comes from its FAO port, there is the MAC source address of the PC. So, it takes the opportunity to fill its own ARP table. Now, the router knows that the IP 192.168.1.10 matches the MAC addresses only with A's. The router then processes the ARP query by replying to the PC that it is indeed the 192.168.1.254, with an MAC address only with C. The PC receives the ARP response to its own request and adds them to its ARP table. The frame that was waiting is sent with the IP address and the source MAC address of the PC. The destination IP address is indeed that of the server of the other subnetwork, but on the other hand, and this is where you have to be careful, the destination MAC address is that of the default gateway. It's not the server's. The destination MAC address is the default gateway. When the router receives this frame, it recognizes its MAC address and processes the package. As the destination IP address is unknown to it, it passes the package to its routing process, which will try to find a match in its routing table. In this example, the destination network is directly connected to it. That's why the package will be routed directly through the fast Ethernet 01 interface. Then the process remains the same as at the beginning, i.e. the router will send an ARP query to find the MAC address that matches the destination IP, the server. The head will be changed, and this time the package will reach the server without any problems. You may notice that the router changes the source and destination MAC addresses, while the source and destination IP addresses remain the same. As for the switches, it does not change the package in any way. When it receives it, it must send it back to the right port, according to its table of MAC addresses.